Hello friends, today in this video I'll be going to talk about a number theory problem which came in ISI BMATH BSTAT 2017 and it's problem number 5. So what it says is let G be from n to n, so this is from the set of natural numbers to the set of natural numbers with G of n being the product of the digits of n. So we need to prove that G of n is less than equals to n for all n belongs to the set of natural numbers. So what we need to prove is that the product of the digits of a number is less than the actual number. So let's try to prove it. So in general, a k digit number is of the form n is equals to, where n is a k digit number, so it's 10 to the power k minus 1 times a k minus 1 plus dot 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 plus a 10 to the power 1 times a1 plus a naught. Okay, so what we actually need to prove, so now what is g of n is the product of the digits, so that is nothing but ak minus 1 times ak minus 2 dot 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 a1 times a naught. So I need to prove that this thing is less than or equals to n, so that's what we need to prove. Okay, so what we'll be concentrating on the first part of this number, that is this part. Okay, so this part itself is greater than the product of the product of all the digits of the number. Why? Because a k minus 1 a k minus 2 dot 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 a1 a naught is less than equals to a k minus 1. Now I'll be replacing all the others by 10 because they are digits. So all the AIs are from 0 to 9. And so 10 times 10 dot 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 10. So it's k minus 1 times. Okay. So this is, since all the AIs belongs to set from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and they are all less than 10. And so the product of the digits, that is from I going from 0 to k minus 1, ai is obviously less than a k minus 1 times 10 to the power k minus 1. And now if I add the others, so it won't harm the inequality because all the others are positive, so I'm just adding positive quantities with it. So 10 to the power so dot 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 plus 10 a1 plus a naught. And see, all the AIs are digits, so they are positive and they are just getting multiplied with some powers of 10 and getting added up. So everything is positive that I'm adding. So this is g of n, and that is n. So g of n is less than equals to n for all n belongs to the set of natural numbers. So we are done with the first part. Now, what about the second part, part B? Now, part B is find all n belongs to the set of natural numbers for which n square minus 12n plus 36 is equals to g of n. So here we need to find. So I mean, this part was interesting. Like, I've been given with given a polynomial, and for the particular value of n, the product of the digits of n will be equals to the value of the polynomial when I put n in that polynomial. So p of n will be equals to the product of the digits of the number. So it was kind of interesting if you think it in that. I mean, think it from there. So now, how do we solve it? So let's write down the polynomial, that is n square minus 12n plus 36. N square minus 12n plus 36. Okay, and this has been given to be equals to, it has to be g of n. And now from the part A, we know that this is less than equals to n. G of n is less than equals to n. So we get n square minus 12n plus 36 is less than equals to n. And solving this, so taking everything on one side, I get n square minus 13n plus 36 is less than equals to 0. And I can factorize what I have on my left, so it's n minus 4 times n minus 9, and this is valid for n belonging to, so all the natural numbers from 4 to 9, and 4 and 9 included because equality is there. So the n's that satisfies this relation are, so all the n's which satisfies are 4, 5, 6, 7, 8 and 9. So it's I mean this relation. Okay, so this inequality I'm talking about, I'm not talking about part B. Okay, so they satisfy this inequality. Now I need to look for the numbers out of them which satisfies part B. And now look, since they are one digit numbers, and for a one digit number, n is equals to g of n, I mean the product. Product is nothing but that digit, and the number is also a single digit. So for this single digit numbers, g of n is nothing but equals to n. And so we need to basically see when the equality holds. And so we need to basically solve for n square minus 12n plus 36 is equals to n. And this is true for n equals to 4 and 9. And so 4 and 9 are the only answer, are the only n belonging to the natural numbers, the set of natural numbers, and satisfying this condition in part B. So we are done with problem 5.